Alright, so now let's remind us of what the definition is of information content, entropy, cross-entropy, and KLDivergence. KL stands for Kullback-Leibler. These are the people that invented that concept. And we have an experiment, we have a random variable x, and x can take the values a, b, c, and d. Let us assume that a, b, c, and d are animals. And so let's assume that c is cat and d is dog, right? Then first we're going to train the model. And of course, when you have a picture of a dog, the distribution you will get is 0, 0, 0, and 1. This is your real distribution. As this is supervised learning, you actually can see that the picture is a dog, right? Now when we train the model, so you're going to get to your model H, and the model H is going to produce a softmax output with distributions, or with probabilities, of each of these. And here I've taken these probabilities. So, in this case, you also will decide that it's a dog. But it's only with a probability of 60%. Yeah? So the model has another distribution, and this is your approximate distribution. Yeah? And now we're interested to see how close our model is to the reality. Yeah? And that's what we will try to calculate. In order to get there, we need to define what information content is. Yeah? And information content is 0 if your information doesn't add any value. So in the case of training here, what is the probability that your x is a dog? If that probability is 100%, if it's 1, this doesn't give you any information. Yeah? So that means that the information content is inversely proportional to the probability. And now if we want to get this probability up, we're going to take minus the log. Yeah? So the information content of a distribution P is minus the log of P. Alright. Now we're going to define entropy as the expected value of the information content. Yeah? So what is the expected value? Well, it's the average information produced by your stochastic process. And so entropy is H of P is written as minus the sum of P log P. That looks very much like an expected value formula. And that's not a coincidence. Now we can go one step further and look at cross entropy. Yeah, what is cross entropy? Well, we denote it by H, P, and then this symbol Q. And the cross entropy actually gives you the distance between two distributions, P and Q. Yeah, so here you already compare the two distributions. And then KLDivergence, basically the sum for KLDivergence is that it's the sum of P times log P over Q. Yeah, KLDivergence gives you how similar two distributions P and Q are. KL is always positive and is non-symmetrical. Yeah. And basically you see that your cross entropy here equals your entropy plus KLDivergence. So if P and Q are close to each other, this term needs to go to 0. And when does it go to 0? Well, very easily. If Q equals P, it's the log of 1, which is 0. Yeah. So here you have your two entropies, and if you need to add to P to get to Q, you're still away from P. It's only when you don't need to add anything that Q and P will be similar.